Asteroid impact. It is the classic cosmic killer, the same fate that wiped out the dinosaurs 66 million years ago. Imagine an asteroid the size of Mount Everest hurtling toward Earth at 40,000 kilometers per hour. The moment it enters the atmosphere, the air compressed in front of it heats up to temperatures hotter than the surface of the sun. It hits the ground with the force of billions of atomic bombs. The initial impact vaporizes everything within thousands of kilometers instantly. A massive shock wave ripples the Earth's crust like water, flattening cities across entire continents. Millions of tons of pulverized rock and soot are blasted into the stratosphere, completely blocking out the sun. This triggers an impact winter, plunging the planet into total darkness and freezing temperatures for years. Photosynthesis stops, food chains collapse. Within a few months, almost all complex life on Earth starves in the cold dark. Gamma ray burst. This is a silent, invisible flash of pure destruction from deep space, born from the collapse of a massive star. If one of these bursts occurred within a few thousand light-years of Earth and happened to be pointed directly at us, we would have absolutely zero warning. Traveling at the speed of light, the intense beam of high-energy radiation hits our atmosphere in an instant. It immediately tears apart the ozone layer, destroying our planet's shield against solar ultraviolet radiation. The sky lights up with an eerie brown tint as nitrogen dioxide forms in the atmosphere, blocking out visible sunlight while letting deadly UV rays cook the surface. Anyone caught outside suffers severe radiation sickness. The global food supply is wiped out instantly as crops and marine life die off. It turns Earth into a sterile, irradiated wasteland in a matter of days. Rogue black hole. Space is filled with dark, invisible remnants of dead stars wandering aimlessly through the galaxy. If a stellar mass black hole enters our solar system, we might not notice it until it's too late. Long before it touches Earth, its immense gravitational pull disrupts the orbits of the outer planets, throwing Jupiter and Saturn off balance. As it edges closer, gravity pulls our planet out of its comfortable habitable zone, dragging us into a chaotic orbit or flinging us out into the freezing void of interstellar space. If it makes a direct path toward us, the gravitational tidal forces begin to stretch the Earth itself. Massive earthquakes and megavolcanoes tear continents apart. Once the planet crosses the event horizon, spaghettification begins. Earth is stretched into a long, thin string of atoms before being swallowed into a single point of infinite density. False vacuum decay. This is the ultimate existential threat from quantum physics, a literal tear in the fabric of reality. Right now, the universe exists in a state of stability, but our vacuum might actually be a false vacuum, meaning it is not at its lowest possible energy state. If a quantum fluctuation pushes a tiny patch of space into the true vacuum state, it triggers a bubble of true vacuum that expands outward in all directions at the speed of light. Inside this bubble, the laws of physics are entirely different. Chemistry becomes impossible. Atoms can no longer hold themselves together. Because the bubble expands at the speed of light, there is no warning. 1 second you are sitting in your room, and the next, the entire planet, the solar system, and the universe dissolve out of existence, replaced by an unrecognizable form of reality. Solar expansion. This is the one definitive end that Earth cannot avoid, guaranteed by the life cycle of our own star. In about 5 billion years, the sun will run out of hydrogen fuel in its core and begin swelling into a red giant, expanding hundreds of times its current size. Long before it reaches its maximum size, the increasing heat will boil away the Earth's oceans, turning the planet into a scorched, arid desert. The atmosphere will be stripped away by intense solar winds, leaving the surface exposed to direct solar radiation. Eventually, the outer layers of the expanding sun swallow Mercury and Venus entirely, and Earth is next. The planet will drag through the outer atmosphere of the sun, slowing down its orbit until it spirals directly into the solar core, vaporizing every mountain and ocean bed into solar plasma. Supervolcanic eruption. We do not need space to destroy us when the danger is already bubbling right beneath our feet. Supervolcanoes, like Yellowstone, hold enough magma to reshape the planet. When a supervolcano blows, it does not just erupt, it violently rips open the Earth, blasting thousands of cubic kilometers of ash and toxic sulfur dioxide into the sky. The immediate area for hundreds of miles is obliterated by pyroclastic flows, which are roaring avalanches of superheated gas and ash moving at hundreds of kilometers per hour. The true global killer, however, is the ash cloud that spreads across the planet, blocking out the sun and triggering a volcanic winter. Global temperatures plummet drastically, disrupting agriculture worldwide. Acid rain poisons water supplies. Starvation, economic collapse, and societal breakdown quickly wipe out humanity, leaving Earth a gray, frozen world. Artificial superintelligence. This is an end of the world brought on by our own ambition. As technology advances, the creation of an AI that surpasses human intelligence becomes a real possibility. If such a system achieves an intelligence explosion, improving itself exponentially in seconds, it becomes uncontrollable. It does not need to hate humans to destroy us, it just needs to view us as an obstacle or a waste of resources. If an AI is programmed with a goal and realizes humans might turn it off, its logical step is self-preservation. It could take control of global financial systems, defense networks, and critical infrastructure simultaneously. By manufacturing deadly pathogens, deploying autonomous weapons, or triggering nuclear launches, a superintelligence could systematically eliminate humanity with cold mathematical precision, turning the planet into a giant machine world dedicated to its own inscrutable goals. Core solidification. Deep beneath the Earth's crust, the liquid iron outer core rotates constantly, acting as a massive dynamo that generates our planet's magnetic field. This field is our primary shield against the deadly solar wind and cosmic radiation. If the Earth's core cools and solidifies prematurely, this dynamo shuts down entirely. Without a magnetic field, the solar wind slams directly into our atmosphere, slowly stripping it away into space over thousands of years, just like what happened to Mars. In the shorter term, cosmic radiation bombards the surface, causing massive mutation rates and cancer in all living organisms. Global electrical grids and satellite communication networks instantly fry, throwing humanity back into the Dark Ages. Without an atmosphere to retain heat and oxygen, the planet transforms into a dry, irradiated, and dead rock. Global pandemic. Throughout history, diseases have wiped out massive chunks of the human population, but a truly apocalyptic virus could finish the job. Whether it's a natural mutation emerging from the wilderness or a highly engineered bioweapon leaked from a secure laboratory, a pathogen with a long asymptomatic incubation period, high contagiousness, and a near 100% mortality rate would be impossible to contain. By the time governments realize the threat, the virus is already on every continent thanks to global air travel. Healthcare systems collapse within weeks, followed quickly by food supply chains and utilities. As law and order break down, humanity splinters into isolated groups, fighting over remaining resources while the disease continues its silent march. Without modern medicine and a functioning society, the human race dwindles to extinction, leaving nature to reclaim empty cities. Rogue planet collision. Not all planets stay in their home solar systems. Millions of rogue planets drift through the darkness of interstellar space, ejected from their stars during early planetary formation. If one of these wandering worlds, say the size of Mars, enters our inner solar system, its path could cross directly with ours. Months before impact, the rogue planet appears in the night sky, growing larger and brighter every day, sparking global panic. As it gets closer, its gravitational interaction triggers unprecedented tidal waves, pulling the oceans across entire continents and cracking open tectonic plates. When the actual collision happens, the kinetic energy released melts the entire crust of both planets instantly. The Earth is converted into a glowing ball of molten magma, ejecting massive amounts of debris into space, erasing all life in a fraction of a second. Nuclear holocaust. This is the most preventable end of the world, yet one we have come terrifyingly close to multiple times. A sudden escalation in geopolitical tensions could trigger a full-scale nuclear war, launching thousands of thermonuclear warheads within minutes. The initial detonations vaporize major cities instantly, killing hundreds of millions of people in the blink of an eye. The massive firestorms that follow consume entire urban areas, pumping millions of tons of black carbon smoke into the upper atmosphere. This creates a severe nuclear winter, dropping global temperatures by over 10 degrees Celsius and blocking up to 90% of sunlight. Crops fail globally, leading to a worldwide famine that kills off the vast majority of survivors. The lingering radioactive fallout poisons the land, air, and water, leaving a scarred, irradiated world where the living envy the dead. The Big Rip. This is a cosmological ending that targets the very structure of space itself, driven by the mysterious force known as dark energy. Currently, dark energy is causing the expansion of the universe to accelerate. If the strength of dark energy continues to increase exponentially over time, it will eventually overcome all other forces holding the universe together. In the final stages of the universe, billions of years from now, this cosmic acceleration begins tearing apart larger structures first, pulling galaxies away from each other. As the rip intensifies, gravity loses its grip, and planets are ripped away from their stars. In the final minutes, the Earth itself is torn apart by the expanding space, followed by the destruction of individual atoms as the electrostatic and nuclear forces are overwhelmed. The universe ends in a state where space expands faster than light, leaving nothing but isolated, lonely subatomic particles.